So here we are provided that the derivative of vector A with respect to t is given by the vector product between v and a, and the derivative of vector B with respect to t is given by the vector cross product between v and b. Using these two facts, we need to prove that the derivative with respect to t of a cross b, this is given by v cross a cross b. So let's find it out. So first, we will find the derivative with respect to t of a cross b. So here we'll have to use the product rule. So first we'll take derivative with respect to t of our vector a, then we will cross it with vector b, then add it to vector a and cross it with derivative with respect to t of vector b. Now we are provided with derivative of a vector with t, so that's v cross a, so we will substitute with v cross a, crossed b plus a vector crossed with derivative of vector b with respect to t, so that's given by v cross b. So here we know that vector cross product anti-commute, meaning if we have a cross b, so that's simply equals to negative times b cross a. So here using this, we can also rewrite our first term as negative times b vector crossed with v cross a plus a vector crossed with v cross b. Now what we have is the vector product of three vectors. We can use the vector product of three vectors. Let's say we have vector a crossed with b cross c, and to expand this, all we have to remember is the mnemonic back cap. Back cap means we first take the vector b and multiply it to the dot product between vector a and c, minus we take the vector c and multiply it to the dot product between vector a and b. So we'll use this back cap method, this mnemonic, to expand each of the two vector triple product. So the first one will be, we'll take negative common. So here b vector corresponds to v, so we have v vector multiplied to b vector dotted with a vector, minus, so next we have to take c vector. Here c vector corresponds to a vector, so we have a vector multiplied to b vector dotted with v vector. Similarly, we use the same mnemonic, so this will become v vector multiplied to a vector dotted with b vector minus b vector multiplied to a vector dotted with v vector. So we'll distribute this negative 1 with each of the two terms within the parentheses. So we have negative times v vector multiplied to b dot a plus a vector multiplied to b vector dot v vector plus v vector multiplied to a dotted with b minus b vector multiplied to a dotted with vector v. So here we will see that the first term and the third term cancels out. They are exactly the same. So we are now left with a vector times b vector dotted with v vector minus b vector multiplied to a vector dot v vector, and this is nothing but the vector triple product of v vector crossed with a cross b. So we started with by taking the derivative with respect to t of a cross b, and we obtain v vector crossed with a cross b. So this is what we are asked to prove, hence proved.